Lock it down!
Move those planks, keep the line straight.
At this rate, the crossing will be impossible by nightfall.
And the fog gives us no cover. We must report this immediately.
All right, easy now. Watch the current. Heave! Secure that clamp down tight. Bring the next section up. Let's move.
January 1945. A thick, ghostly fog drifts over the frozen Rhine, shrouding the river in silver-gray mist. On the far bank, German engineers huddle in stunned silence, their breath clouding in the frigid air. Their measuring tools tremble in their hands, not from cold, but from disbelief. Across the water, American soldiers move with uncanny precision. Planks, cables, and something unimaginable. Giant rubberized sections are being laid, forming bridges that seem to float effortlessly on the swollen river. The Germans whisper among themselves, eyes wide, questioning their training, their assumptions, their very understanding of engineering. The water laps gently against the pontoons, yet the movement feels electric, almost unnatural. Soldiers march across. Vehicles rumble. Artillery pieces trundle over the flexible surface without a hint of hesitation. Every step, every vehicle crossing, defies what the Germans had considered possible. They had studied maps, anticipated obstacles, calculated currents, but nothing had prepared them for this. In the stillness, punctuated by the occasional metallic creak and muffled splash, one thought spreads silently among the German ranks. The Americans had turned a river into a road, and the rules of war had just changed. By late 1944, the Western Front was a landscape of shattered towns, bombed-out roads, and rivers that had long served as natural defensive lines. The Allies, having landed in Normandy months earlier, had pushed relentlessly across France, breaking through German defensive positions and advancing toward the heart of Germany. Every mile gained was a testament to combined armed strategy, logistical planning, and the sheer determination of soldiers facing both the enemy and the unforgiving terrain. Rivers, in particular, had proven to be formidable obstacles. For the Germans, the Rhine and its tributaries were not just watercourses. They were barriers, strategic choke points, and symbols of security. Bridges were heavily defended, often mined, and quickly destroyed in retreating maneuvers. Conventional military doctrine expected that any crossing would be slow, costly, and bloody. Engineers were trained to anticipate delays, to fortify crossings, and to hold ground until reinforcements could arrive. The United States Army, however, approached mobility differently. American doctrine emphasized speed and flexibility, a philosophy honed from campaigns in North Africa and Italy. The U.S. Army Corps of Engineers had, for years, experimented with portable bridges, pontoons, and even inflatable structures designed to carry infantry and vehicles across water obstacles. By 1944, these innovations were no longer theoretical. They were battlefield-tested tools, ready to be deployed on a scale that few Germans could imagine. In the dense planning rooms of the U.S. Ninth Army, engineers pored over maps, calculating river widths, flow rates, and soil conditions on both banks. Their goal was clear: maintain momentum at all costs. Delays at river crossings meant giving the Germans time to regroup, reinforce, and strike back. Yet traditional timber and steel bridges were vulnerable, slow to assemble, and prone to destruction. To overcome this, American engineers had embraced something unconventional: rubberized and floating bridge components. Light enough to transport on trucks, flexible enough to adjust to currents, and surprisingly resilient under weight. These bridges were a secret weapon of ingenuity rather than brute force. German intelligence, on the other hand, remained largely unaware. Reconnaissance reported the usual patterns: American artillery concentrations, supply convoys, and infantry formations. What German engineers did not realize was that their assumptions about materials, engineering standards, and logistics were about to be challenged in real time. They expected a conventional crossing, timid, calculated, and predictable. What awaited them instead was audacious, improvisational, and disturbingly effective. The stage was set along the Rhine in early 1945. Rivers that had seemed insurmountable barriers now became testing grounds for engineering innovation. Every officer and soldier on both sides understood the stakes. For the Americans, a successful crossing meant continued momentum toward the heart of Germany and potentially shortening the war. For the Germans, failure could accelerate collapse, exposing lines of retreat and leaving cities defenseless. Even among the engineers themselves, there was tension and anticipation. German engineers, steeped in centuries of methodical practice, could not fathom bridges that could float, flex, and support armored vehicles simultaneously. American engineers, conversely, moved with calm efficiency, trusting in both design and training. The contrast in preparation and mindset was stark, a prelude to the shock that would unfold on the misted riverbanks. As dawn approached on the Rhine, the water reflected a muted light. The air was filled with a mix of frost and expectation. On one bank, German engineers sharpened tools, checking calculations and surveying the terrain. On the opposite bank, Americans assembled modular bridge sections with practiced precision. One side anticipated routine engineering challenges. The other anticipated disruption, innovation, and the element of surprise. The river, silent and cold, awaited the coming clash of human ingenuity and disciplined training, a moment that would redefine how bridges were used in war. The tension on the riverbank was more than military. It was philosophical. It was the collision of tradition against innovation, expectation against reality, rigidity against adaptability. And as the fog began to lift, the Germans would soon see firsthand that American military engineering had rewritten the rules of crossing a river under fire. The story of America's rubberized and floating bridges began long before the Rhine crossings of 1945. U.S. military engineers had faced rivers, canals, and flood-prone terrain across multiple theaters of war, from North Africa's deserts to Italy's mountainous valleys. Early experiments with pontoon bridges and modular components proved that mobility could be enhanced without sacrificing load-bearing capacity. By 1944, these experiments had matured into fully operational designs, capable of supporting everything from infantry to medium tanks. Among the most innovative developments were rubberized bridge components, sections constructed from reinforced rubber and metal frameworks. These units could float on water, adjust to varying currents, and be quickly assembled by small engineering teams. Unlike traditional wooden or steel bridges, which required cranes, heavy vehicles, and significant manpower, these bridges could be laid across rivers in a fraction of the time. The flexibility of rubber also meant they could absorb the weight of heavy vehicles without catastrophic failure. The military doctrine behind these bridges emphasized speed, surprise, and adaptability. Engineers were trained not only to assemble bridges, but to do so under enemy fire, often at night, in fog, or in adverse weather conditions. Portable power tools, folding pontoons, and prefabricated sections enabled units to cover dozens of meters in mere hours. In exercises conducted along rivers in southern France, these bridges had proven capable of supporting artillery units, armored vehicles, and supply convoys, all while remaining mobile enough to be relocated as needed. The Germans, for their part, relied heavily on traditional engineering principles. Steel trusses, reinforced concrete, and timber were their standards. German doctrine anticipated that any river crossing by the Allies would be methodical, vulnerable, and predictable. Reports from reconnaissance occasionally noted American engineering activity, but intelligence underestimated both the speed and creativity of U.S. bridge-building capabilities. The Germans expected bridges to be static, immobile, and easily targeted by artillery or demolition teams. The Rhine River, one of Europe's largest and most strategic waterways, presented a challenge unmatched by any previous theater. Its currents were strong, banks were often steep, and German defenses were well established. Observers noted the river as a formidable natural barrier, a defensive line that could delay the Allies for weeks. The Americans, however, viewed it differently. For them, the Rhine was not a barrier. It was an obstacle to be overcome, a temporary challenge that would not impede their momentum. To meet this challenge, U.S. engineers prepared meticulously. Floating bridge sections were pre-assembled, transported to staging areas under camouflage, and rehearsed repeatedly to ensure seamless deployment. Each section was designed to interlock with the next, forming continuous spans capable of handling vehicles weighing upwards of 30 tons. Small infantry teams were trained to defend the assembly process, while supporting artillery provided suppressive fire against German positions. It was a combination of logistics, technology, and battlefield tactics designed to render traditional German assumptions obsolete. The human element was equally crucial. American soldiers and engineers displayed confidence rooted in rigorous training and extensive field experience. Unlike the Germans, whose disbelief stemmed from rigid adherence to textbook principles, the Americans trusted innovation. They understood that the success of these bridges was not simply a matter of materials. It depended on timing, coordination, and adaptability. Mistakes could be fatal, but training minimized error, allowing them to operate almost like clockwork. Previous smaller-scale tests foreshadowed the Rhine crossings. In Belgium and along the Moselle, portable bridges had enabled rapid troop movements, catching German defenders off guard. Engineers observed how quickly armored units could traverse rivers, and commanders noted the psychological impact on enemy troops who witnessed obstacles vanish seemingly overnight. By the time U.S. forces reached the Rhine, experience, technology, and doctrine converged. The Germans were about to confront a reality that challenged everything they knew about military engineering. As American bridge sections were loaded onto trucks and moved toward the Rhine banks, the stage was set for an operation that would be remembered not for large-scale battles alone, but for the ingenuity and audacity of men turning a river into a highway. Across the fog-shrouded water, German engineers prepared their calculations, unaware that their assumptions would soon crumble. The coming moments would be as much a test of human perception as of steel and rubber. This rising anticipation naturally leads into exploring angles, the multiple perspectives that reveal how this seemingly simple engineering feat had profound tactical, technological, human, and psychological implications on the battlefield. On the misted banks of the Rhine, the human reaction was immediate and visceral. German engineers, trained in methodical precision, stared in disbelief as American soldiers laid what seemed to be impossibly light, yet sturdy bridges across the river. Eyes widened, jaws tightened, and murmurs rippled through the ranks. For years, these engineers had built bridges to exacting standards, steel beams bolted into place, timber planks carefully measured, calculations verified. Now, they watched men marching confidently over rubberized, floating structures, carrying artillery, trucks, and even tanks without a single collapse. It was not just engineering that was being defied, it was expectation. The Germans' understanding of battlefield logistics and material science was being challenged in real time. Some scribbled notes, frantically, attempting to reconcile what they saw with what they had learned in military academies. Others simply froze, unable to respond. The psychological impact of witnessing ingenuity so audacious had a ripple effect. Hesitation in command decisions, delay in defensive deployments, and an underlying sense of vulnerability. For American soldiers, however, the human aspect was different. Confidence and training underpinned every movement. Teams worked in near silence, trusting in each other and in the design of the bridge itself. Every man knew his role, every step was choreographed, and every potential hazard accounted for. This calm human precision contrasted sharply with German shock, amplifying the element of surprise. The tactical advantage of these bridges lay in their capacity to preserve momentum. Traditional river crossings were slow, methodical affairs. Engineers needed hours, sometimes days, to construct stable bridges, all while under potential enemy fire. The rubberized bridges, however, allowed American forces to bypass these limitations entirely. Infantry, vehicles, and artillery could cross in a matter of hours, transforming rivers from defensive barriers into transit corridors. Commanders on the American side understood that speed was decisive. Every minute saved during a crossing reduced exposure to enemy artillery, minimized casualties, and maintained the initiative. The Germans, trained to anticipate predictable sequences, found themselves reacting instead of acting. Defensive positions intended to target bridgeheads proved ineffective against these rapid deployments. Entire tactical plans had to be adjusted on the fly, a testament to how a seemingly minor technological shift could disrupt battlefield calculations. Moreover, the mobility of the bridges allowed engineers to deploy multiple crossings simultaneously. Where one section faced resistance or damage, another could be assembled downstream. This redundancy multiplied tactical options, keeping German defenders off balance and contributing to the Americans' broader operational objectives, advancing into German territory while minimizing attrition. At the heart of the operation was an extraordinary piece of military engineering. The rubberized bridge sections represented a fusion of materials science, hydrodynamics, and practical battlefield innovation. Reinforced rubber panels provided flexibility and buoyancy, while embedded metal frameworks offered structural strength. Sections interlocked to form continuous spans capable of supporting vehicles weighing several tons. The design incorporated modularity. Units could be transported on trucks, assembled rapidly on site, and disassembled or relocated as needed. Floating pontoons absorbed water currents, maintaining stability even under dynamic loads. Engineers had anticipated weight distribution, buoyancy fluctuations, and current patterns, resulting in a structure that was not only functional, but surprisingly resilient. This technological leap was amplified by American training. Soldiers and engineers practiced assembling these bridges under simulated combat conditions, refining techniques until speed and precision became second nature. The Germans, familiar with rigid steel or timber bridges, could scarcely imagine such versatility. Their disbelief was not mere surprise. It was a confrontation with a completely new paradigm of military engineering, one that rendered decades of conventional knowledge suddenly inadequate. As these perspectives illustrate, the Rhine crossing was more than an exercise in brute force. It was a complex interplay of human reaction, tactical ingenuity, and technological innovation. Soldiers on both sides were engaged not only in combat, but in an encounter with the unexpected, a test of adaptability, observation, and courage. The unfolding moment set the stage for examining leadership decisions, enemy responses, and psychological effects. The remaining angles that reveal the full impact of this extraordinary engineering feat. For commanders on both sides, the Rhine crossing presented a test of judgment, adaptability, and nerve. American leaders had invested months in preparation, ensuring that every bridge section, every engineering team, and every infantry unit was ready for rapid deployment. Their decisions were guided by meticulous planning, identifying optimal crossing points, timing artillery support, and coordinating logistics to keep the operation fluid. Confidence in their subordinates' training allowed them to delegate critical tasks, focusing on synchronization across multiple units. German commanders, in contrast, were confronted with an unpredictable situation. Their doctrine anticipated methodical advances by the Allies, slow river crossings, and predictable points of attack. When American forces began deploying flexible, rubberized bridges at unexpected locations, German officers faced immediate uncertainty. Defensive positions had to be reassessed, artillery redeployed, and contingency plans improvised. The shock was compounded by the speed and audacity of the operation. Decisions that normally required hours of deliberation now demanded rapid response. Hesitation, even momentary, could, and did, result in tactical disadvantage. Leadership under such stress highlighted a stark contrast between American foresight and German rigidity. From a German point of view, the Rhine had always been a natural line of defense. Engineers and infantry alike had assumed that the river would slow any advancing force, providing time to mobilize reserves and coordinate counterattacks. The sight of rubberized bridges floating across the current defied those assumptions. Reports from German reconnaissance units conveyed astonishment. Vehicles moving steadily over seemingly unstable surfaces, artillery pieces crossing intact, and infantry marching confidently as if the river were a paved road. This technological disruption translated into operational confusion. German units, expecting predictable points of assault, found themselves outflanked. Defensive artillery fire often fell short or struck empty banks. Units tasked with demolition or sabotage were too slow to react to the mobility of American engineers. The cumulative effect was disorientation at every command level, undermining morale and delaying coordinated responses. The enemy's mental model of how rivers should impede movement was collapsing, replaced by a new reality where speed, innovation, and audacity dictated outcomes. The psychological impact of these bridges extended beyond tactical considerations. For German soldiers, witnessing an American force crossing with minimal resistance created a sense of vulnerability and disbelief. Decades of training, military doctrine, and engineering knowledge were challenged in minutes. Reports from the field describe stunned silence, muttered disbelief, and a pervasive feeling that the enemy had somehow rewritten the rules of engagement. For American troops, the effect was empowering. Confidence surged as each section of the bridge went into place and vehicles rolled across. Training, preparation, and trust in equipment reinforced morale. Soldiers understood that success depended on teamwork, timing, and precision. This psychological advantage proved critical. Troops operating under stress maintained composure, executed their roles flawlessly, and exhibited initiative when unforeseen challenges arose. The combination of technological innovation and disciplined execution created a feedback loop. As the enemy wavered, American confidence increased, amplifying the effectiveness of the operation. Moreover, the bridges themselves became symbols of ingenuity and resourcefulness. In a war defined by destruction and attrition, a simple engineering innovation demonstrated that creativity could rival firepower. It was a lesson in the human capacity to adapt and overcome, leaving an impression that resonated long after the immediate tactical victory. The convergence of these angles, leadership, enemy confusion, and psychological impact, reveals the full depth of the operation. What may have seemed a simple river crossing was in reality a multidimensional achievement, blending planning, technology, and human resolve. The Germans were forced to confront the limits of their assumptions. The Americans demonstrated that warfare could be transformed not solely by weapons, but by innovation, adaptability, and precision. February 1945. The Rhine lay before the Allied forces like a wide, cold artery cutting through the heart of Germany. Early morning mist curled over its surface, concealing both opportunity and danger. On the western bank, American engineers and infantry prepared for one of the most audacious operations of the European campaign. Every man knew that success depended on speed, coordination, and trust in the untested rubberized bridges. The Germans, entrenched on the far side, anticipated another slow, laborious crossing, but what awaited them would defy expectation. The first pontoon sections touched the icy water just after dawn. Small teams of engineers moved swiftly, lowering floating rubber units into the current, connecting them with precision. The mist reduced visibility to mere meters, adding both cover and tension. Commanders checked watches, shouted terse instructions, and scanned the far bank. German artillery, positioned to target traditional bridge points, hesitated as they saw the unconventional structures emerging. Their calculations, weight distribution, current speed, structural limits, were rendered meaningless by this innovation. Infantry were the first to test the bridges. Soldiers stepped cautiously, boots meeting the rubbery surface with a slight give, but the span held. Confidence grew with every step. Engineers followed in parallel, securing additional sections, reinforcing weak points, and preparing lanes for vehicles. In less than an hour, the first trucks rumbled onto the floating spans, their engines rumbling over the flexible surface. Tanks, weighing over 30 tons, soon followed, their treads leaving impressions on the rubber, but no cracks, no failure. On the German side, shock rippled through command posts. Field officers called for recalculations, artillery teams attempted fire adjustments, and engineers scurried to assess the new threat. Yet the American operation continued unabated. Every movement was deliberate, rehearsed, and synchronized. Communication lines buzzed with updates, ensuring that engineers, infantry, and armor remained coordinated. The Rhine, once a formidable natural barrier, was being transformed into a conduit for rapid advance. The tactical impact was immediate. German units assigned to defend the river were forced into reactive positions. Artillery fire often overshot or struck empty water. Machine gun nests aimed at predictable crossing points now found themselves bypassed. The American speed and precision not only preserved momentum, but created confusion and hesitation within the enemy ranks. Soldiers on both sides experienced the clash of expectation against reality. Germans struggling to adapt, Americans executing a plan that had been honed through months of preparation. Amid the chaos, human elements became decisive. Engineers on the American side displayed extraordinary discipline, moving under the occasional burst of artillery and sniper fire. Communication signals passed quickly, and minor obstacles were addressed without panic. The psychological advantage, nurtured during training and reinforced by successful bridge assembly, proved as critical as the engineering itself. Confidence surged as every crossing validated months of planning. By mid-morning, a continuous stream of vehicles, including half-tracks, supply trucks, and artillery pieces, traversed the Rhine. The Germans scrambled to respond, moving reinforcements toward unexpected crossing points, but the rapidity of American movement outpaced their efforts. Command decisions, normally deliberated over hours, had to be made in minutes, often with incomplete information. The imbalance between preparation and reaction tilted the operational advantage decisively toward the Allies. This first phase of the crossing, the initial deployment of troops, vehicles, and artillery, set the stage for the climactic engagement. The Germans were now forced to confront a reality that shattered their assumptions. A river that had been considered impassable could be crossed efficiently, silently, and under pressure. The Americans' combination of engineering ingenuity, tactical foresight, and disciplined execution created a turning point not only in the local engagement, but in the broader campaign across the Rhine. As the morning fog began to lift, the full scale of the operation became visible. Rubberized bridge sections stretched across the river. Armored units were already pushing inland, and artillery units prepared to provide covering fire. German engineers, still grappling with disbelief, attempted to devise countermeasures, but the initiative had shifted irrevocably. The moment of crossing was complete. What remained was consolidation, expansion, and a relentless advance into German territory. The operation had reached its decisive phase, yet the final outcomes, the German response, the broader strategic impact, and the transformation of the battlefield were still unfolding. The second part of the climax would show how the Americans exploited their advantage, how German units reacted under pressure, and how a simple innovation reshaped the immediate campaign. By late morning, the Rhine crossing had moved beyond a test of engineering into a full-scale operational maneuver. American forces, flowing steadily across the rubberized bridges, began consolidating positions on the eastern bank. Infantry units secured beachheads, while armored divisions fanned out to establish perimeters and block potential counterattacks. The precision and speed of the crossing left German commanders scrambling, their forces disoriented and struggling to mount a coherent defense. The Germans attempted to strike back. Artillery units fired at suspected crossing points, but the mobility and redundancy of the American bridges rendered much of the bombardment ineffective. Engineers on the U.S. side were trained to adapt. Damaged sections were quickly repaired or bypassed, and additional floating units were deployed downstream to maintain continuity. Tanks and trucks continued their steady advance, their weight no longer a threat to the seemingly fragile structures. The psychological impact on German soldiers intensified. The river, once an obstacle, now appeared as a highway for enemy forces, a realization that undermined morale and fueled a sense of helplessness. Command decisions became frantic. German units repositioned hastily, often moving into areas that were already secured or exposed to American fire. Reports from the front described confusion among officers and enlisted men alike. Bridges were everywhere, vehicles were crossing at multiple points, and defensive plans were obsolete before they could be implemented. The Americans' control of tempo, the ability to dictate the speed and sequence of action, proved decisive. The initiative had irrevocably shifted across the river. By early afternoon, the full weight of the operation was visible. Artillery units, once held in reserve, now provided covering fire for the advancing troops. Infantry, spread across the eastern bank, secured towns and crossroads that would serve as staging areas for the next phase of the advance. Logistics units followed closely behind, moving fuel, ammunition, and supplies over the rubberized bridges to sustain the momentum. Every element of the crossing, engineering, combat, logistics, was synchronized, a demonstration of operational mastery underpinned by innovation. The consequences were immediate. German forces, unable to mount a coherent counterattack, began to retreat in some sectors. Defensive lines crumbled under the combined pressure of mobility, firepower, a psychological shock. Reports from German officers later emphasized the unprecedented nature of the operation. One noted, "We could not believe our eyes. Bridges, floating, moving vehicles, everything seemed unreal." The language reflected not exaggeration, but genuine astonishment at a military innovation that redefined expectations. For the Americans, the successful crossing represented more than a tactical victory. It validated months of training, research, and experimentation. It demonstrated that ingenuity, discipline, and preparation could overcome formidable natural and human obstacles. The bridges, flexible yet resilient, were no longer tools. They had become symbols of operational supremacy, enabling forces to maintain momentum and surprise in a theater where hesitation could mean disaster. By evening, the Rhine was effectively crossed. Units were establishing strong points, supply lines were functional, and forward reconnaissance was probing deeper into German territory. Casualty reports were favorable, a testament to both planning and execution. German forces, demoralized and scattered, were forced to regroup, delaying any effective counteroffensive. What had begun as an audacious river crossing had become a decisive turning point, one that would influence subsequent operations and shape Allied strategy in the region. The climax of this operation highlighted a fundamental truth. Warfare was no longer solely about firepower or numbers. Mobility, innovation, and the ability to exploit engineering breakthroughs could yield results disproportionate to the size of the force involved. By redefining how rivers could be crossed under combat conditions, the Americans had set a new benchmark for operational flexibility. German engineers and commanders were left to reconcile what they had observed with long-held assumptions about the limits of military engineering. As the night fell over the eastern bank of the Rhine, the bridges stood firm, armored vehicles lined up for the next day's advance, and soldiers prepared for the continuation of a relentless push into the heart of Germany. The moment of crossing, the turning point, was complete. The consequences, both immediate and long-term, were now beginning to unfold, shaping the aftermath of the operation and leaving an indelible mark on the European campaign. The morning after the Rhine crossing, the eastern bank was a scene of controlled chaos and triumphant accomplishment. American soldiers and engineers moved methodically, securing positions, repairing minor bridge damages, and preparing for the next stage of the advance. The rubberized bridges, once an audacious experiment, had proven their reliability under combat conditions. Vehicles, artillery, and troops moved seamlessly across the water, enabling the Allies to maintain a pace that the German forces could neither anticipate nor match. For the Germans, the crossing was a psychological shock as much as a tactical setback. Reports from engineers and officers described disbelief at the sight of vehicles rolling across seemingly flexible structures. Defensive lines had been bypassed, artillery fire rendered largely ineffective, and infantry units were caught off guard by the speed and audacity of the operation. German command struggled to comprehend how the Americans had turned a natural defensive barrier into a thoroughfare for rapid advancement. In many cases, retreat was the only viable option to preserve remaining forces for defense deeper inland. The consequences on the battlefield were immediate. American forces seized key towns, road junctions, and supply depots along the eastern bank. These footholds provided staging areas for continued advances into the German heartland, enabling artillery, armored divisions, and logistics units to flow forward without interruption. Casualty numbers, though still significant, were lower than expected for a river crossing operation of this scale, a direct result of speed, surprise, and engineering innovation. Field reports from American engineers emphasized the operational success of the rubberized bridges. Minor adjustments were required where currents were stronger or riverbanks uneven, but the structures proved capable of supporting armored vehicles weighing upwards of 30 tons. This validation of pre-war research and rigorous field testing underscored the critical role of engineering innovation in modern warfare. On the German side, the impact extended beyond immediate tactical losses. Engineers, whose training emphasized rigid calculations and predictable outcomes, were forced to revise their understanding of bridge technology. Manuals and standard operating procedures could not anticipate flexible, floating bridges capable of bearing heavy loads under combat conditions. Commanders, confronted with this operational surprise, began reassessing defensive doctrine for river crossings, considering not just artillery placement, but reconnaissance of potential engineering innovations. Soldiers on both sides felt the human weight of the event. American troops carried a sense of accomplishment and morale uplift, having executed a complex operation under stressful conditions. German soldiers, conversely, experienced disorientation and diminished confidence. Observers later noted that the visual shock of seeing vehicles traverse what was considered impossible had a lasting effect on morale, affecting combat readiness in the days following the crossing. Historical records, including after-action reports and eyewitness accounts, highlight the significance of this operation. The success of the rubberized bridges demonstrated the interplay of technology, training, and tactical execution in achieving objectives previously thought improbable. The Rhine, a river that had long symbolized German defensive strength, was no longer an obstacle. Instead, it became a conduit for rapid Allied mobility, signaling a shift in operational momentum that would influence the remainder of the campaign. The immediate aftermath also included practical lessons for both armies. American engineers documented the crossing meticulously, noting both successes and potential improvements. German forces, meanwhile, began analyzing captured sections of the bridges, attempting to understand their construction, materials, and load-bearing capabilities. This post-operation evaluation foreshadowed changes in German defensive planning and highlighted the broader strategic implications of engineering innovation on modern warfare. The stage was now set for examining the broader consequences and long-term impact of the operation, how these bridges influenced subsequent Allied movements, affected German strategic thinking, and shaped the course of the European campaign. As the Rhine crossing stabilized, the broader strategic implications became clear. The Americans had secured a foothold that allowed their forces to continue the advance into central Germany with unprecedented speed. Supply lines, previously constrained by destroyed bridges and difficult terrain, now flowed uninterrupted. Artillery, armored vehicles, and infantry units moved forward with coordination, transforming a river that once defined a natural defensive line into a launch pad for continued operations. The Germans were forced to adapt quickly. Field reports from late February 1945 reveal a mixture of disbelief and pragmatism. Engineers and commanders analyzed the rubberized bridge technology, attempting to understand its construction, buoyancy, and load distribution. Recommendations were made to fortify future river defenses not only against traditional crossings, but against innovations that could circumvent existing strategies. However, the rapid pace of the American advance meant that many of these adaptations were too late to influence the outcome of the campaign. Numbers reflect the operational success. Within 48 hours of the initial crossing, multiple divisions had established positions across the Rhine. German forces, caught off guard, suffered disorganization and logistical setbacks. Although exact casualty figures varied, reports suggest lower than expected Allied losses, highlighting the efficacy of speed and surprise over brute force in this engagement. German retreating units abandoned equipment and defensive positions, further accelerating the Allied advance. The success of the bridges also had lasting implications for military engineering. Manuals were updated, training programs adjusted, and the concept of rapid deployment, flexible bridging became a standard consideration in modern operations. The Americans' ability to integrate innovation with tactical planning set a precedent, demonstrating that ingenuity could be as decisive as firepower in warfare. Military historians have since noted that the Rhine crossing exemplified the evolution of operational art. The seamless integration of technology, human skill, and command decision-making under combat conditions. First-hand accounts reinforce this narrative. Engineers recalled the precision required to lay the floating sections, while infantry and armored unit commanders emphasized how critical the bridges were to maintaining momentum. German officers, meanwhile, repeatedly cited the crossing as a moment that defied conventional expectations. One German report described the scene. "We watched vehicles roll across what we considered impossible. Our understanding of engineering failed us." Such statements underscore the shock and lasting impression the operation had on both sides. Beyond the immediate campaign, the operation influenced broader Allied strategy. By proving that rivers could be crossed quickly and reliably, planners gained confidence to attempt similar maneuvers in future operations, reducing reliance on static front lines and conventional engineering constraints. This mobility allowed for more aggressive offensive planning, ultimately contributing to the collapse of German resistance in the final months of the war. The operation also illustrated the psychological dimension of innovation. The bridges, simple in concept yet revolutionary in execution, demonstrated that creativity and adaptability could unbalance an opponent before combat even began. German troops, trained to expect obstacles to delay or channel attacks, were confronted with a force capable of negating those obstacles entirely. The ripple effect extended beyond the battlefield, shaping enemy decision-making and influencing the course of operations across the Western Front. As the Rhine crossings concluded and American units advanced further into German territory, the combination of strategic advantage, operational speed, and engineering innovation became evident. The bridges had not merely enabled movement. They had reshaped the battlefield, forcing both sides to reevaluate assumptions about mobility, engineering, and the psychological aspects of warfare. The consequences of this operation naturally lead into reflection, a moment to consider the broader historical, technological, and human significance of turning rivers into highways, of innovation overcoming expectation, and of courage and discipline ensuring that ingenuity translated into decisive action. The crossing of the Rhine in early 1945 stands as a testament to the power of human ingenuity in war. What might have seemed a simple engineering feat, a bridge laid across a river, became, in reality, a symbol of innovation, discipline, and audacity. Rubberized, floating bridges defied expectation, challenged tradition, and redefined what was possible under combat conditions. They were more than tools. They were a statement that warfare could be transformed not only by firepower, but by creativity, coordination, and calculated risk. For the Americans, the operation demonstrated the profound value of preparation and adaptability. Soldiers and engineers, trained to act with precision under stress, turned a theoretical innovation into a decisive battlefield advantage. For the Germans, the crossing forced a confrontation with the limits of doctrine, revealing that assumptions, no matter how long held, could be overturned by ingenuity and speed. Disbelief, shock, and eventual adaptation highlighted a crucial truth. Warfare is as much a contest of minds as of material and manpower. The broader lesson extends beyond military history. The Rhine crossing illustrates how obstacles, natural or man-made, can be overcome through creative problem-solving and collaborative effort. It underscores the importance of flexibility, the willingness to challenge convention, and the courage to act decisively when opportunity presents itself. In that foggy morning on the Rhine, innovation triumphed, not through spectacle, but through careful planning, discipline, and human determination. Historically, the operation accelerated the Allied advance into Germany, shortened defensive lines, and demonstrated the potential of engineering to shape campaigns. But its enduring significance lies in the human story. Men confronting doubt and fear, relying on training and ingenuity, and transforming a river from barrier into bridge. The Rhine crossing reminds us that even in the destruction of war, innovation and human creativity can leave an indelible mark, proof that progress often arises from the bold application of intellect, courage, and vision. In the end, the river no longer symbolized limitation or obstacle. It became a conduit for possibility, a testament to the enduring power of human ingenuity, in a moment where history witnessed that even the most rigid expectations can be reshaped by daring minds and determined hands.